What if there was a computer so powerful that it could answer questions no ordinary machine could ever solve? A computer not limited to zeros and ones, but capable of exploring countless possibilities all at once. This is the mystery and promise of quantum computing. Let's begin by comparing it with what we already know. A classical computer, like the one you use daily, is built on tiny switches called transistors. These switches represent either a 0 or a 1, never both. But a quantum computer doesn't follow the same rules. In a futuristic lab, scientists are building machines that operate on the principles of quantum physics, where information exists in strange, uncertain states. So, what is a quantum computer? Unlike a laptop that processes bits, a quantum computer processes qubits. A qubit is special. Thanks to quantum mechanics, it can represent a 0, a 1, or both at the same time. Imagine exploring a maze. A classical computer tries each path one after another. A quantum computer, with its qubits, explores all the paths simultaneously. This makes it fundamentally different, an entirely new way of computation. But how do these qubits work? Their power comes from two key phenomena: superposition and entanglement. Superposition allows a qubit to hold multiple values at once. Picture a glowing sphere existing in many states simultaneously. Entanglement is even stranger. Two qubits can become linked, so that what happens to one instantly affects the other, no matter the distance. This is what Einstein once called spooky action at a distance. These properties give quantum computers exponential processing power, far beyond what classical machines could achieve. What can quantum computers actually do with this power? They can simulate molecules for drug discovery, helping scientists design new medicines. They can analyze financial markets with unprecedented accuracy, giving bankers and economists sharper tools. They can optimize flight paths, saving fuel and reducing pollution. Astronomers may use them to model the universe, while pharmaceutical labs could discover treatments for diseases faster than ever. Industries around the globe, healthcare, energy, aerospace, finance, are all watching quantum computing closely. But the journey is not without challenges. Qubits are fragile. They collapse if disturbed by heat, light, or noise. That's why quantum machines must be kept in cryogenic chambers, colder than outer space. Error correction is another battle. Scientists are inventing complex methods to repair unstable calculations. And then there is security. Quantum computers could one day crack modern encryption, forcing us to invent new quantum-proof communication systems. Today's prototypes are impressive, but we are still in the early stages, much like room-sized computers of the 1950s. Still, the possibilities are breathtaking. Imagine students learning quantum science in futuristic classrooms. Picture AI robots collaborating with humans, powered by quantum processors. Think of space exploration, with ships guided by quantum navigation systems. Even our brains may one day merge with quantum circuits, unlocking new forms of intelligence. The Earth itself could glow with the light of quantum connections, transforming how humanity lives, learns, and explores. Now that we understand what quantum computers are and how they work, let's ask a bigger question. How will they transform our world in the coming decades? The future of quantum computing isn't just about building faster machines. It's about solving humanity's greatest challenges.
In cities around the globe, researchers imagine using quantum power to design smarter energy grids, reducing waste and cutting carbon emissions. In classrooms, teachers could guide students through live quantum simulations, turning abstract physics into vivid experiences. In the field of medicine, scientists dream of curing diseases like cancer or Alzheimer's by simulating molecules too complex for today's tools. Pharmaceutical breakthroughs that once took decades could happen in years or even months. Finance and security will also change. Banks could rely on quantum computers to model risk with pinpoint accuracy, while new quantum cryptography would protect our personal data from cyber threats. Governments and corporations are already racing to develop these secure systems before quantum machines reach full maturity. But perhaps the most exciting vision lies beyond Earth. Imagine spacecraft powered by quantum algorithms navigating the vast distances of our solar system with precision we can barely imagine. Quantum computers could help us explore distant planets, predict cosmic events, and maybe one day unlock secrets of the universe itself. The road ahead is long. Challenges remain, and breakthroughs will not come overnight. But the trajectory is clear. Quantum computing will not replace classical computers, it will complement them. Just as calculators didn't replace human thinking, and supercomputers didn't make laptops obsolete, quantum machines will work alongside our current technology, reserved for the problems that truly demand their extraordinary power. So as we stand on the edge of this new era, the question is not whether quantum computing will change the world, it's how soon. And when it does, it may reshape science, industry, and even human civilization in ways we are only beginning to imagine.
Quantum computers aren't science fiction anymore. They're becoming science fact. From solving problems that could take today's supercomputers millions of years to creating new breakthroughs in AI, climate science, and healthcare, the potential is limitless. Yet this power also comes with responsibility. Questions of ethics, accessibility, and security remain. The quantum era is not just about faster machines, it's about reshaping the world we live in. And as this story unfolds, one thing is certain: quantum computing is not the end of the journey, it's only the beginning.